So we have our next speaker, Poretsky, Director of Security North America and from Ericsson. And again, Scott has been a frequent speaker in our many IEEE events. He's also an IEEE leader with CQR, one of the founding members. In addition to that, he has been very active in Open RAN Alliance security. I knew Scott since my AT&T days. So without wasting Scott's time, you have the bio here. Scott, welcome you to the next talk. You got 20 minutes? Yeah.
Yeah, all right.
Yeah,
yeah, and this is a
no, he's going to yeah, old bio.
This is an old bio. So
yeah,
and thank you, Ashutosh, for having this. This is the third year in a row you're doing this event, and there's always been very interesting talks. In fact, I found Chi-Ling and Tracy's presentations very interesting. That bio you showed is somewhat old. I'm now, in addition to being Director of Security for Ericsson North America, I am also co-chair of the O-RAN Alliance Working Group 11, where we've been making great progress improving the security posture of O-RAN, and we're doing that based on a zero trust architecture. And it's a good thing that we're doing that. And how do I flip? This way?
Yeah, just next.
Next. There. And it's good that we're securing Open RAN, O-RAN with a zero trust architecture, because our mobile networks are critical infrastructure. These are the backbones for society. In fact, the German BMI, the Ministry of the Interior, said public 5G mobile networks are an integral part of critical infrastructure. And isn't it rewarding that we get to work on something that is so important for society? Our communication, our economy, our public safety is built upon this secure, reliable mobile infrastructure. And it's important we secure that because we see threat actors evolving and the types of threats are evolving. Perimeter security alone is no longer sufficient. The traditional way of securing a system was to secure it out at the perimeter. But that no longer works because if threats have evolved, they've been able to establish beachheads inside of systems and move laterally. And there they're lying dormant, performing reconnaissance, and waiting to cause disruption at the appropriate time. That has changed our thinking. It's evolved the way we think about securing systems. It's no longer that traditional perimeter security. It's about securing internal to the system as well. All of the internal functions, all of the internal interfaces. And that's what's called the zero trust architecture. Now, fortunately, 5G is the most secure generation of mobile to date. 3GPP did a great job building in security with 5G. But it's not perfect. It's not there yet. We're continuing to progress towards a zero trust architecture. And you see those efforts ongoing now in both the O-RAN Alliance and 3GPP, and also in ADIS, by the way. There are new threats, or there's an expanded attack surface being introduced with 5G and next generation mobile networks. And that's because of new technologies we see coming into these future generations of mobile networks. Cloud native, APIs, AI, ML, and openness in itself. And it's not just me saying this. I think there's a very important quote here that I put in the black box at the bottom of the slide. So the NSA has something called an Enduring Security Framework. That's the NSA's outreach for collaboration with industry. And there was a study which that addressed security guidance for 5G cloud infrastructures. And I highly recommend this set of documents. It's like the playbook for how to secure 5G in the cloud. 4 volumes, 100 pages. And in there it says 5G networks, which are cloud native, will be a lucrative target for cyber threat actors. To counter this threat, it's imperative that 5G cloud infrastructures be built and configured securely. So there's our mission statement right there. So if we're going to build in a zero trust architecture with Open RAN, we need to first look at where the risks are, particularly due to the openness. There's a lot of advantage to having an open architecture. It can result in increased performance, and it also accelerates innovation. In ORAN, we have the openness introduced in 4 places, and we'll start with the top of the stack. And maybe I can have that microphone. No. There we go. So if we start at the top of the stack, that's where we have the SMO, the service management and orchestration. The SMO is now being architected with a service-based architecture, breaking up all of the functions and services inside the SMO with a service-based architecture that uses a service-based interface. All of those functions and services become known now as SMOSs, SMO services, and SMOFs, SMO functions. This decoupling of the SMO enables more vendors to provide individual SMOSs and SMOFs just within the SMO. So we have openness within the SMO. Then, with the non-real-time RIC and the near real-time RIC, we have XApps and RApps. Those are purpose-built applications by best-of-breed software vendors that are able to integrate within the RICs. That further expands the openness of the ecosystem. Then, of course, we have the very well-known open front haul interface. You'll see in red here the ODU and ORU. That's where we're breaking up the RU and DU functions and introducing an open front haul interface. This enables different vendors to provide radio units, further enhancing the openness of this architecture. And then something a lot of people miss, so I really want to highlight it here. In ORAN, we have something called OCloud. It's not just a cloud. The ORAN Alliance is specifying its own requirements for running ORAN network functions in the cloud. And this ORAN specified cloud is called the OCloud. So we are going to have additional openness because you can have different vendors providing all of these different functions and elements throughout the ORAN architecture. Oh, and I do want to highlight one other NSA ESF quote that I put down here. The deployment of Open RAN introduces new security considerations for mobile network operators. By nature, an open ecosystem that involves disaggregated multi-vendor environment requires specific focus on changes to the threat surface area. So this is saying we're introducing all of this openness. We need to make sure we secure it because this is introducing new risks. This is in the ESF study on ORAN security considerations, which I was a part of. This was published, I think it was a year ago. It might be more than that now. So if we're going to protect from internal and external threats, we need to have a zero trust architecture. There's 4 principles of a zero trust architecture. The first one is network functions and architectural elements are secured as micro perimeters. So if we go back to this architecture diagram that's here, we're not just creating a perimeter around all of this, but now each of those functions, each of those blocks is secured as a micro perimeter. And each of those internal interfaces is also secured because that's principle number 2. We have confidentiality and integrity protection provided for data in transit on external and internal interfaces. And then, of course, we also protect our data at rest and data in use. Then number 3, authentication and authorization are enforced on a per session basis for external and internal subjects. Nobody is granted implicit trust including internal actors, because we can have those advanced persistent threats where there's somebody already inside the network maliciously moving through the network with the intent to cause disruption and also for reconnaissance. Then that brings us to our fourth principle, and that's continuous monitoring, logging, and alerting. By having that, we're able to detect and respond to security events. It really serves as the foundation for these other three principles, because you can't achieve this level of security without the visibility. And the continuous monitoring is what gets us that visibility. Now, those are four principles that are based off of what NIST calls the 7 tenets of zero trust. And when you have 7 tenets of zero trust, you have a zero trust architecture. 4 of these 7 tenets have been rather straightforward for standardization and building of products and deploying of networks. Those 4 are tenets 1, 2, and 3, and tenet 6. Tenet 1, all data sources and services are considered resources. 2, all communication is secured regardless of network location. 3, individual resources are granted on a per session basis. And then 6, authentication and authorization are dynamic and strictly enforced. That is straightforward in being achieved. However, the other 3, tenets 4, 5, and 7, are more challenging. These rely upon still evolving technologies. For example, tenet 4 is about dynamic policy, which relies upon AI. We're still building AI into our networks, and we're not there yet with dynamic policy. The standardization of dynamic policy is also a challenge. Then with tenets 5 and 7, that's about continuous monitoring and the data collection to feed into our continuous monitoring. Tenets 4, 5, and 7 are great opportunities for further study, standardization, and innovation. So if you're looking for areas where you can make an impact into an Open RAN network, focus on tenets 4, 5, and 7. And that's advice for IEEE. Yes. Okay. So ZTA in ORAN, we've done a lot of specifications so far. It's a lot to do. I ran through those 7 tenets of zero trust. It takes time, it takes money. You can't have a zero trust architecture on day one. Now, fortunately, CISA, the Cybersecurity Infrastructure Security Agency, came up with what they call the zero trust maturity model. It's about a phased approach to get to a zero trust architecture because it takes time and money. The first phase is traditional. That's the traditional perimeter security, the way we had been doing it. That's no longer sufficient. The second stage is initial. Those are your first steps towards implementing the internal security to protect against internal threat actors, protecting your internal interfaces, protecting your systems, your specific functions within the system. Advanced means it's pervasive across your system, and you've built in automation for that. Then in the final stage, optimal, it's fully automated with AI ML. So you have all of this dynamic intelligence detecting and responding to your events. It's in the optimal stage where you'll see the continuous monitoring, dynamic security policy, and AI ML. You'll see in the text here there's black text with security controls, and there's purple. I don't know if the purple shows up in the audience. The black text means it's in the ORAN specifications today. Purple means it's what we are working towards right now. In the ORAN Alliance Working Group 11, we have 14 different security work items addressing many of these topics, particularly around continuous monitoring, dynamic policy, AI ML security. We're also looking at container hardening, secure onboarding, MFA as well. So the work is continuing on those purple items, and we have a few minutes, yes, we do, that we can take a look into some of these interesting topics. How to secure AI/ML in our RAN, RApps and XApps, the O cloud, and APIs. AI/ML is a paradox because AI/ML can be a very powerful tool for enhancing security. It can give us that intelligence we need to better detect and respond to security events. At the same time, AI/ML can also be a very powerful tool for our adversaries to attack a network, to attack a system. And then AI/ML inside the system is also part of the attack surface. AI/ML can be exploited by threat actors. So it's very important that we secure our AI/ML that's used in ORAN, in the non-real-time RIC, in the near real-time RIC, in the SMO, in our RApps and our XApps. And as Chi Lin showed earlier, AI/ML is used throughout the ORAN architecture, and there are many different AI/ML assets across that architecture. There's the data, the training data, the inference data, network function input data, and performance feedback data. We have the initial and trained models, and then we have the training host, the inference host, and model management host. We need to be able to operate with AI/ML securely in our RAN. In the ORAN Alliance Working Group 11, we have a dedicated work item for securing AI/ML in Open RAN, and we're using as our guidance for that security the OWASP Top 10. I'm sorry, are you trying to point to me? We're doing questions at the end. So there's the OWASP Top 10. We are implementing our security controls based upon those top 10. That work is just beginning. We've completed our study item, and we're continuing to move forward with that standardization. So that's the first of those 4 blocks. The next one is RApps security. And RApps are very interesting because RApps can be a very powerful tool for enhancing the security posture of an ORAN deployment, because we can leverage that AI/ML, build it into RApps, and have this visibility across the network. Because the RApps have all of this visibility through the O1 interface and through the O2 interface to all the different network functions. So the SMO is really aware of everything that's going on with all of this data. And the RApps have access to all of this data through the R1 interface. That makes it a prime spot to start building software applications that can detect and respond to security events. And it can respond to security events by pushing down policy through that A1 interface to the near real-time RIC. However, it's also a paradox because the RApps are a significant security threat. They are a security threat on the supply chain because RApps can come from third-party vendors being integrated into the SMO. And once you're in the SMO, you really have the keys to the castle. You can go anywhere across your ORAN deployment. So we need to make sure that there is a secure supply chain with the RApps and that they are being securely onboarded. We also need to make sure our RApps are built with secure APIs and they're using strong identity and access management controls. So that would mean we're using certificates for authentication, and we're also doing authorization. Many of these controls and mitigations have already been specified in the ORAN Alliance security specifications. All of these listed down here. And that ensures that when we're integrating RApps into our SMOs, that that's done securely. Then we have the O cloud as well. And we talked about all of these places where we're opening up the ecosystem. And in the O cloud, you can have your vendor A that's providing your O cloud hardware infrastructure. You can have vendor B that's providing your O-Cloud software infrastructure, and that has an O2 interface up to the SMO from vendor C, which can then have those SMOSs and SMOPs from other vendors, and then it can have inside that SMO also RApps from other vendors. And through that O2 interface, the O-Cloud has access to the SMO, and the SMO has access to the O-Cloud. So we need to make sure that the O-Cloud in that O2 interface is also properly secured. We need the same access controls, API security, supply chain security, secure credential storage, and protect against lateral movement. These security controls are in the process of being specified in Working Group 11. Now, what's interesting on this threat surface that I mentioned here is the Cloud Security Alliance just issued its update to its biannual, so once every 2 years, they publish top threats to cloud computing. So their most recent one just came out 2 weeks ago, so that's really hot off the press. And when you look at the top 10 threats to cloud computing, these threats listed here appear on their list of that top 10. And in fact, number 3 on their list is insecure interfaces and APIs. And people think, I just have APIs, how convenient. They are, they're really convenient. It's a great way, APIs are very valuable for consumers to gain access from, access to information from producers, gain access to information and insights. However, APIs are also a well-known security threat. Number 3 on the CSA's list. That's because APIs have been prone to have vulnerabilities that are exploited out in the wild. So you need to make sure when implementing APIs that they are secure. ORAN uses those APIs across all of its interfaces, and we have specified in the security requirements spec, MTLS and TLS for APIs, OAuth, and making sure you do proper input validation. So 5G is critical infrastructure. We need to secure it appropriately. Zero trust architecture is the way to do it, so we protect against external and internal threats. It should be pursued through incremental stages. Do not try to do it all at once, and do not wait for perfect. Start taking incremental steps now. Working Group 11 is doing that, and we've made excellent progress. We believe we're now in that advanced stage, working towards the optimal stage. In that optimal stage, we're continuing to secure AI, ML, our RApps and XApps, the decoupled SMO, O-Cloud, and the APIs. And then security RApps in themselves can further enhance the ORAN security posture.
Thank you.
Yep, thank you.
All right, let's question, maybe just one quick question you will ask.
Post it in the chat as well.
Okay, you want to answer in the chat? Maybe just let's take a live question. Yeah.
Okay, so I'm an AI ML expert. I'm not a cyber or a network expert, but knowing the space for being 20 years in the tech sector, these are time issues, right? Anomaly detection based on your network, based on processes that are running on the kernel. What kinds of data sets are available to train your models for threat detection, intrusion detection, anomaly detection? Because based on ORAN's open initiative, the way that you guys are embracing this, I would think and hope that those data sets that you're training would be made available for us who are AI ML experts to have access so that you're training and testing it.
Yeah, they're not available yet, but from Working Groups 2, Working Group 3, and the OSC, they will be available in the future. I don't have a time frame for that.
Can we stay in touch with you guys to work with you guys to train the models?
Yes, absolutely.